this, I'll call it fasten assembly. So I have two plates that are sitting on top of each other, and I've taken a bolt or a screw, because usually when it's a bolt, there's a nut there. So either way, so screws, threaded screw, you just tighten it. Now, first of all, you tighten it because, for example, let's again think about the bolt. If you don't tighten it, it defeats the purpose. Why do you want to put a bolt there? Because the whole purpose of putting a bolt there is to clamp these two faces together, these pieces together, tight enough so that they don't, become loose. That's really the purpose. So you don't do that in a random way for a critical issue, critical problem. You have to know how much you have to tighten this, and they'll tell you. Whoever designed the process tell you that bolt has to be at 50-pound pretension. In other words, you have to have used a torque wrench, applied enough torque there, which translates into a bolt load, which holds these two pieces together. Okay? These are not random numbers. So, but this particular problem, I'm going to just use some fake numbers here. So I want a 50-pound pretension in the bolt. And after I do that, then my plate is subjected to a load of, 1,000 pounds on the right side, or 100 pounds on the right side. You can see that the bottom plate is subjected to an edge load or a face load of 100 pounds. And of course, the left side of these things are clamped. Now, first of all, you don't model the bolt unless your job is to design the bolt itself, for example. Something like that. Because look, here's a multimeter, and there are some, they're not bolts, of course, there are screws here, 1, 2, 3, 4, 5, and then maybe I want to throw this thing and find out what the stresses are in here, because that depends on whether it's going to break or not. Now, of course, you can't do something like that with Catia. You have to do some other explicit solver to do that. If you're just dropping it, you don't know what the forces are, etc. But you don't model these. You don't model these bolts, because imagine that it's so small, tiny here. If you wanted to model this thing, you're going to be tiny little elements, which is of the order of maybe 1/10 of a millimeter, and then that has to go with something here, which is probably shell. The surface of this is shell, etc. But the point is that you don't always model bolts. But I want to show you what happens if you did want to model it. Maybe you are in the design of business of designing the bolt itself. And after I'm done with this problem, I'll come back and repeat the same problem without actually modeling the bolt. You lose something. There's no doubt. You lose something. But that's a trade-off. If you have a fuselage of an aircraft with 10,000 rivets, or a pressure vessel top, clamped to the bottom piece with 50 bolts all the way around, it's impossible to model these bolts one by one. It's just you're going to sit there for months before you get any results, for example. Okay, but we're going to do that. One thing you should keep in mind is that if you have a bolt, never cut through it. Because if you look at this problem, you might tell me that, didn't we learn all about symmetry, that there's a plane of symmetry cutting all the way through it? Yes, but that will cut through the bolt, and we don't want to do that. Don't do that, okay? Never cut through the bolt. Maybe in some other packages, they're smart enough, they spend more time so that, that thing works. But not in Catia. I don't guarantee that. If you had two bolts, one here, then I can cut through the part. There's no problem. I'm not cutting through the bolt, but don't cut through the bolt. Okay, so we're going to do this first with modeling the bolt and then without. Any questions here? Okay. So we go there, product. So let me save this thing, file, save management, save as, desktop, desktop, new folder, call it the afternoon class. Okay, afternoon class. Say okay, and okay. Because everything that I do for this particular problem goes into that folder. Any other problem, I put it in a different folder. There's no possibility of having a product one there, having a product here, they overwrite each other. Or a part one there and a part one here overwrite each other. So, yeah. Okay. So I'm going to insert my first part. Insert, new part in there. And I'm going to do the top plate first. Okay. The dimensions and things like that are in the book or in the video later here. If you want to know, here are the dimensions. You can freeze it and find out what they are in case you want to repeat this. Okay, on that plane, first of all, we have to go part design because we want to create something. So on that horizontal plane, I will sketch a 1x1 square and then a hole of radius 0.125 inches. So sketch. So let me, it really doesn't matter whether I center it or not. I will because we're not going to cut it anyways, but it's always a good idea to do this. So here, let me dimension these things. So this is 1 inch there, and 1 inch there. And I'll make a circle of radius 0.125. So this is going to be radius 0.125. 0.125. Okay. Exit. Padded. The thickness of these plates were also 0.125. So I'll make it 0.125. Okay, good. Let's go and insert our second part. I go up there. So insert a new part in there. Say no. By the way, it would have been a good idea to call this thing top and the bottom and then later on the bolt. I didn't do that. Just keep that in mind. So let's go here. So part 2 is my bottom plate. And I did something kind of inadvertently bad. And when I tried to make the part, it gave me an error message. And I tried to figure out what it was. I couldn't figure it out. And somebody told me what the problem was because I projected something on top of itself twice. And that's why it gave me that. So I had to go and clean it up. I'm not going to do that for you. I'm just going to let you know. There are people here who are better than I am, for sure. So anyway, let's make this. So on a convenient plane, and that convenient plane is that same XY plane. Okay. I'm going to, yeah, that's the XY plane. That's the bottom plane. I'm going to sketch a bigger rectangle and a hole and pad. Okay. So, but I'm too lazy. So what I'm going to do is I'm going to say, here's what happened. The mistake that I made, I projected that circle, which is fine. Then I also projected that face. So there's going to be a circle on top of a circle when I try to clean it up and pad it, complete. So there's an extra circle there. So I'm not going to make that mistake here. I'm just going to project that face. When you project the face, it does the whole thing, goes down. It's going to give you a rectangle, yellow rectangle, and yellow circle. Okay, so let me do that. There we are. The mistake that I made, I also projected that hole also. That gives me two circles on top of each other. Okay, so let's look at this. Now, I want to block this because I don't want to see it. That's because I'm lazy. I'm just going to delete this guy and do the rest of it. Do the rest of the rectangle. Okay, so the rectangle, the rest of it was like this. It goes from here to here, to here, there. I just have to dimension this thing to be 1 inch because the whole thing was 2 inches. This is already 1 inch, we know that. So dimension this to be 1 inch. And that takes care of it. Exit and pad it. By the way, let me bring that guy and put it in front. Okay, good. This thing, I'm going to pad it, but in the other, this sketch, in the other direction, also by 0.125. It will not do it because there was an extra circle there saying intersecting, curves and things like that. Good. Now, then we're going to insert the bolt. So we go there. Make sure you save. Okay. Insert new part in there. Say no. Do you know why it's asking you to be why it's pausing? Because notice that every time I say insert, it pauses. I have to go select that thing on the top, and it puts it there. Do you know why it is pausing? Why it could be pausing? Yes. No, it didn't. It didn't reach that stage. When I say insert insert new part, it didn't do anything. It just sat there. I'm going to undo that. Let me show you again. Insert new part. Wait a minute. I have to go to the product. Okay. Insert new part. Okay, that hang in there. Let me try because this is selected here. So let me see. Insert new part. You see? You see? I said insert new part. It's sitting there. It's not doing anything. Select the component to insert the new part in. That's why I go to the top level and put the part in that top level assembly. You see, it didn't ask me that question. My question from you is that why would it be doing this? Why is it not going to put it in that product anyways? Because that product itself may be consisting of other products, and you may want to take this bolt and put it in a different sub-product, basically. In my case, I have a single product, but a product may be made of several different products, each one of them consisting of several parts. That's why it's saying that where do you want to put it? Maybe you don't want to put it in the top-level assembly. Maybe you want to put it in the sub-assembly, okay? But anyway, that is not the case here, so let me undo this. Port number 4, I'm going to let me undo it or delete it. Okay, good. So let's go ahead and make it. Okay, good. Now, on a convenient plane, and for me, the convenient plane is that top one. But it really doesn't matter. I'll use the top one. Okay, so I'm going to project that circle. It's there. Exit. Pad it. In the other direction, reverse direction. That's too much. Maybe I'll go 0.4, 0.3. I'll make it 0.3. You change it if you don't like it. So it comes from the other end, right there. Ordinarily, you have a knot there and things like that. So I'm not modeling the knot because I'm assuming that this actually can be screwed in. For example, it's threaded the bottom plate is threaded and just goes in there. Okay, or top plate. This is fine. Now, but the bolt head is missing. So I'm going to make the rest of it. So on that face, I will sketch a concentric circle with this guy and then pad it upward. Let's make it 0.1. See how it goes. Looks. Okay. So there is my bolt. Okay, good. Assuming everything is made out of steel, the supply material properties to it. There. Metal, steel on that part, and is okay. All right, so we're going to do the rest of the problem, but I'm going to ask you a question. Is it wise or unwise to use a different material for I don't know, the bolt, or yeah, the bolt? Why would it what's your reaction? And what do you have to watch out if you do that? Use a different material. I'm not saying use it or not. All I'm saying is that what is the implication of using a different material, different metal? Yeah. Okay, I understand what you're saying. I understand what you're saying. May not be strong enough to take, for example, that bolt tightening force, etc. Yeah. Okay. Yeah, because corrosion is very possible when you use different materials. Okay, which has to do with chemical reaction. You're anyway. All steel. Can't do it all the time, but what can I do? Okay, so very good. So let's save this. And now we go to generative structure analysis. Catia goes wild when it sees three parts. Immediately it meshes them all. Three solid parts. Let me put it this way. Let me use a different thing. And you can see there should be three of them. What happened? Should be three. They're sitting on top of each other right there. Maybe this is so. Okay, let me hide one of them. Let me hide this. Let me hide that. Or maybe the first one. Hide the first one. There. It was sitting behind the other guy. Right there. That's for the bolt. Size of the bolt smaller, the mesh is smaller. That's the way Catia does it. Okay. Now, if you want to see the mesh, of course, right-click Mesh Visualization and change the render right here. Now, look, we are not discussing here accuracy of these numbers. Definitely, I will not leave the mesh like that. Okay. So, for example, I will use a finer mesh between the two faces of the two plates. I may use finer mesh around the hole. Okay, so we're not discussing that. Okay, you know how to do it. This is probably too small. Okay, let's deactivate this. When I say this is too small, the element for the bolt probably is too small. Okay, so let me also hide this element so that we don't see it. Hide it. Okay, good. By the way, if you want, you can hide the planes. These planes, right? These planes you can hide, and you have to do it 9 times, right? You have to go. There's 9 planes on top of each other. 9 planes. And the reason they're sitting on top of each other is exactly when I inserted the part, I said don't use another coordinates, another origin. They're all same. So just to remind you how to get rid of this, I think there's a search something here. Where's the search? Search right there. Search, and then you say okay. So there's a we can do part or product. This step is not critical. Actually, let's leave it the way it is. I'm going to say planes. Type planes. Plane. Search and select. Okay, I guess no problem. Oh, I said plan. Okay, so let's see now. First of all, let's go back here. View. Search. Maybe I should use part design here. I don't know. And then plane. plane. Search and select. There. And then I can go hide the stuff. I can do it from here. All gone. Or I could have gone to the tree, said all 9 of them would have been selected. And because if there's 50 planes, there's no way you can do it one by one. You don't want to do it one by one. Good. Move on. So first of all, this end is clamped and that end is clamped. And the top plate does not go through the bottom plate. That's what I know. Okay, so I'm going to create a connection between the bottom of this and the top of the other plate and make that contact. Unless you're specifically told these are perfectly bonded, perfectly glued, perfectly welded, which you make it fast. Okay, as if it was machined like that. But this is not. I bought 2 plates and put it on top of each other. One does not penetrate the other one. So let's make a connection here. And it's a good idea to give these meaningful names. Let's say top, bottom, plate, plates. Okay, first component, the top of this. For the second component, hide that and take the bottom of that. The order is not important here. And while we are at it, immediately we make that thing contact. You know where to do that. Face-to-face connection properties. This is fastened. This one is contact. Don't fool around with these numbers. Okay, good. Now, here, also, I have to tell the software somehow that this bolt that is going to be exerted in there in a minute has a pretension of 50 pounds. Okay, for that, you have to make a connection between the shank of the bolt and the bottom hole. Okay, somebody asked me, what if I do it with the top hole? I said, go try it. Okay, it may or may not work. I don't know. Bottom hole, shank, bottom hole. Okay, I'm pretty sure it's going to work even if you take the bottom one, but I'll leave it to you to worry about it. So I create a connection between the shank, first component being the shank of this bolt. For the second component, the hole of the second plate that I hit. So right there, okay, it's this hole right there. And we say, okay, so maybe I should have given it a different name. Instead of leaving it like that, I say shank, bolt, bottom plate. How about that? Bottom plate. So that you know what you have done. So, okay. Now, this connection that I created is very special. So under face, you're familiar with the contact, you're familiar with the fasten, you're familiar with the pressure fit. This one we did it last week. The one at the very end, it says bolt tightening connection. Bolt tightening connection. It looks like a bolt. You click on it, it says, where is your connection? Well, it's that thing that I created. And what is the tightening force? I put 50 there because I did the problem an hour ago. Okay, the problem says 50 pounds of tightening. Okay? There we are. These are not random numbers. In real life, there's specific values. You do it too much, you're going to strip the bolt. You do it too little, the 2 plates are not going to be clamped together securely. But anyway, you do it like this. Now, notice that there is a pull-down menu which says same and opposite. Now, with the same, that it did it by itself. I didn't do that. It varies from case to case. The direction, there is a bolt there. You can see that. There is a bolt sitting there in that icon. The direction of it is exactly how I want to tighten this bolt. In other words, put the bolt from the top. If you try the other direction, opposite, this will flip. That guy will flip. And one will work, the other one will not. Always the one that you want to do for sure. I mean, my experience is that it works. So this is not right. It will run, but the thing will not actually tighten together. Okay, so I'll do it exactly the way I wanted it, like this. And we say, okay. Now, I'm not even going to put a force on this. You know, the bottom plate was subjected to a force of 100 pounds. We're not going to do that. All I did was to put these two together and tighten it. Let me see what happens. Let's see what happens. So let's run it. The bottom plate is in hiding. That's okay. It's going to come back. Don't worry about it. Hiding because I had to do something. It's there. It's just that. You can't see it. Good news, it's running at least. Okay, good. So let's look at the deformation. Okay. So this is to remind you that it is there. There. You can animate it if you want. So this bolt has no idea that it cannot penetrate the top plate. Okay? That's why it will run, but it's totally useless. So you have to tell the software that, hey, the bolt head, the bottom of the bolt head cannot penetrate the top of that upper plate. Okay? So let me do that for a second. We know how to do it, right? Deactivate this, create another connection. Where's my tree? This is slowing down, and that's not the good news. It has something to do with this recording, I'm pretty sure. Okay, deactivate this. Okay, and let me change the rendering here. All right, so we do another connection, and I'm going to call it bolt head. How about that? Bolt head, top plate. Bolt head, top plate. For the first component, I select the top plate. For the second component, I hide the top plate and select the bottom of the bolt head. Again, you know that the order doesn't matter. This is just creating a connection. Relative, friends, enemies. That's it. You're not saying how. And now this is going to be contact. Okay? So this connection that I created right there, you can see that. We're going to make it contact. On this, we say OK. And then we run it again. While this is running, you remember for your test, you have to submit the product, all three parts, and the analysis. Okay? In the event that we ask you capture the image from the screen, because there is no other way of doing it, you capture the screen, also put it in the place that you have to put it in. And we'll talk about that next week. Haven't decided whether we're going to use Blackboard or create folders for you in the Y drive and you dump stuff in your Y drive. We'll find out. I'm inclined towards the second one. I don't want to fool around with Blackboard. See, always a good idea to save the stuff before you run. In case you have to Control Alt Delete, kill the Catia program that we can do it on our computer, then at least you haven't lost the stuff. Done. So let's look at the deformation. There we are. Okay, let me change the material rendering to material shading. Few things here. Let me first double click and only show the stuff that I'm interested in. Notice that between the two plates, there are all those weird lines. Those are internal contact elements that are created and we're not interested in it. Okay, so let me just say, don't show me that stuff. Just show me on the selection, just show me the mesh, not the contact mesh connection, etc. Just this mesh. That's the bottom plate, top plate. This is the other mesh, which is the bottom one. and there is the bolt. Where's the bolt? Yeah, the bolt. We are not discussing accuracy here. First of all, notice what happened. The top of the bolt, which was a bolt head, which was flat, now it goes kind of down. Okay, that's because of the way the software is implementing the pretension. It's as if sucks it in, but it can't penetrate because of that contact that they put in there. And there's no load here, by the way. There's no load on the part. It's just because of the tightening that you see any deflection. If you look at the von Mises stress, again, total garbage, of course. But let me just show us the stuff that, for example, needless to say, I'm sure you agree with that. That pretty much all the stress is in the bolt. Because what do these two plates do? Okay, they press on each other, I understand, but it's the poor bolt that is holding them together. So that's why everything is masked. For the plate is masked. There's no reason to look at the plate here if you don't want to. So I'm going to double click on this and say, don't show me those guys. Just show me the bolts. That's the last one. There we are. You see? You couldn't see that before because the other guys were blocking it, etc. If you want to look at the plate, the top plate, for example, you go there, double click on it. You can double click it from here or from the tree and say, okay, just show me the top plate. The top plate is that guy. There we are. We could not see that because the bolt stress was actually masking it. Okay. Now, if you want to see everything, no problem. Show me everything. And there we are. Now, there is a problem. The level of confidence that I have in these things or accuracy depends on the extent that you model these things. For example, look, this bolt was exactly the same size as the hole because I projected same size. When you tighten it numerically, it actually goes sideways to the hole and it penetrates it. So in reality, you have to create a contact between the shank and the top hole, the shank and the bottom hole, and say, don't penetrate. Right now, I don't know, because these are almost zero clearance there. As soon as it deforms, it goes sideways, one way or other. It penetrates it. So the level of these things, modeling will tell you how reliable these things are going to be. Now, if this was a bolt that had a clearance there, a bigger clearance, slim bolt, even if it bends, it doesn't go through the sides. But you don't have bolts like that. So if you can make it, but they're not used because then you have to have the nut. The nut is very small hole. Anyway. All I'm saying is that numbers, garbage. You have to do more than just pretty graphs, figures. Now, I haven't even put the load there. This was just tightening it. So let's go ahead and deactivate this. Deactivate this. Now we go and put our load on the top plate, on the side plate. Hide and show. Okay, let's bring everything in the front. I don't know, hide and show. Okay, good. Now, let's put 100 pounds. 100 pounds. Where's the force? Right there. Force on the edge, on the face, whatever. I'll put it on the, on the face. I'll put 1,000 actually here. Okay, 100 pounds. Run it. So you not only have the bolt tightening effect, you also have the load that actually you want to apply to that bottom plate. It's definitely that recording. These are simple problems. Shouldn't take that long. Done. So now we look at the, for example, the, I don't know, let's look at the deflection. There we are. It's all this garbage element is also showing here. These are contact element. But anyway, you can see that uh, the other problem that I did, you probably didn't pay attention to the numbers. Although numbers are not reliable, it was almost zero deflection for the maximum deflection. But here you can see that you have a 0.03 deflection, and it's all this displayed. And these are tied together. These are tied together with that compression force of 50 pounds. Okay. Any questions here? Okay, so I want to repeat this problem, except that I don't want to model the bolt. Okay, so let me save my analysis, although I don't need it, but I'll save it. Analysis, save as, in that folder called, did I call it afternoon? What folder is this? Afternoon, yeah, that's good. Okay, so I tried to do this thing with the other group. Somehow it bombed out, so I made both parts. I don't know why it bombed out. Let me kill this, and let me kill this on purpose. I'm going to start a product file. Okay, and why don't I save it in the same place, by the way? So file, save management, save as, but I'm going to call it product 2 because there is already a product 1 there. Okay, I'm going to call it product 2 because there is already a product 1. I don't want to ruin this thing. I say okay. And those two other parts, the top plate and the bottom plate, I don't want to do it again. Already saved it so I can bring it in. So insert existing component. In there, it says, well, what is it? There is the afternoon. This is not you guys. Afternoon right there. There we are. There was a part 1 and 2, right? Part 1 and 2. So this is why it makes sense to give these meaningful name. Top plate, bottom plate, bolt, etc. But I know what they are. So it's this guy and that guy. There we are. This thing, because I projected it, a surface came with it, but I don't need it. I'm going to hide it. I can't delete it because I projected it. Remember, I projected that entire face. Good. No more bolt. If I save it, it's going to be fine. Product 1 is not product 1. It's a bad idea to leave this thing as product 1 name. It's a good idea to change this thing. You get confused, because there is already real product 1 there. But let's save this. Good. Now, apply material to it. Metal, steel on that. And I'll say okay. Very good. And then we're going to go to generative structure analysis. Catia measures the two parts, the top plate and the bottom plate. There is no bolt here. There's no bolt. Okay, fine. Some of the stuff we already know. For example, well, first of all, let's make clamp these. Yeah, create a contact between the top plate and the bottom plate. So connection between the top plate, just like before, hide this thing. Bottom plate. I'll say top, bottom. Okay. And this is going to be contact. We know that. So let's go ahead and make it. Face. This is the only toolbar that we have used so far. Face. Contact is there. So we're going to select it. And we say OK. And if it's helping you, well, I'll bring this thing so that you can see it too. So it created a contact connection between top and the bottom. Now, I don't want to model the bolt. And obviously, something is going to give in. Because if I don't model the bolt, the stress distribution is not going to be as accurate, possibly, as the bolt being modeled. I cannot see the stresses in the bolt because there is no bolt. Okay? So you create a virtual bolt so that it ties the two pieces together. So you create a connection, top hole and the bottom hole connection first. So you create a connection just like before. Top hole, second component, bottom hole. We created the connection. I should have given it a name here, but I didn't, so I just left it the way it is. So you are familiar with this face-face connection because you have used contact, you have used fasten, have used the pressure fit, and have used the bolt tightening connection that we did half an hour ago, 5 minutes ago. So you can find that thing here. Now notice that in the connection property, there are two toolbars. One of them is the one that we just looked at, face-face. This one is the one that I just showed you. But right next to it, there's another one which says distant connection property. Distant. We have never used this. It's the first time we're using it, and we will be using it in the next 3 lectures that are left for a hybrid analysis too. But if you look at these, look at what it says. First one says, I think, rigid. Okay. Next one says smooth. Okay. Next one says virtual bolt tightening connection property. Ooh, that looks like it. The one next to it, it says virtual bolt tightening connection, virtual spring bolt tightening connection. The difference between the two of them is that the stiffness of the bolt can be put in there, not the bolt modeling the bolt, but the stiffness of it can be put in there in the last one. Okay, but in the one that I showed you, the third one, we assume that actually this bolt is rigid. That's why this is the one that I want to use. It says, well, what is it? It's this last one that I created. Notice that it also puts that bolt up there. Remember, we had to flip it in case it's needed. That direction has no relevance in this problem. In other words, if somebody did it with the bolt down, the other guy did it with the bolt up. If it's a virtual one, it's not going to make any difference. But for the true one, it does. It has to be the way you're going to mount that bolt. So, and the value 50, and you say, okay, then we're going to run. It's going to tighten these two together, but there is no bolt. I can't get the stress underneath the bolt head because there is no bolt. There is no bolt head. Well, but maybe if you have a 50 bolts in a pressure vessel all the way around, you don't want to model each bolt, then you do basically 50 of these, and it's a lot easier. So we say, okay, or rivets in an aircraft, the same story. Okay, so look at deflection, no problem. No, there's no force here, by the way. I haven't put the force there. It's just I tightened it. That's all. With a virtual board, I tightened it. There. And if you don't want to see this garbage in the middle here, double click. Don't show me all that, those internal element, important element, but I don't use it. We don't use it. Internally it's used. So just show me the mesh that I created and this one, and there is no bolt. There is no bolt. And then you can put the load if you want at the end. It makes no difference. So that's the story behind virtual bolts and bolts. Of course, bolts are more accurate, but it's not feasible, may not be feasible.